Exponential graphs are graphs which are in this form: y equals a to the power of x, where a can take any constant. A could be 2, making 2 to the power x. It could be 3 to the power x, 7 to the power x, e to the power x, and so on. And now if you're wondering what e to the power x is, we're going to talk about that very soon. It's a very special number. Now if you want to experiment how they look like, you could make a table of values like this. Choose many values of x, find out the y values, and start drawing it. So if you've got some time, do have a go at doing that. I'm going to show you a rough sketch of how it looks like. So here we've got y equals 2 to the power of x. So it's a graph which gets steep very quickly. And there's a couple of things you should notice about it. It will never touch the x-axis. It will get closer and closer to the x-axis as you go towards the left, but it will never touch the x-axis. Hence, the x-axis is an asymptote. Reason being is you can never choose a value of x, which makes 2 to the power x come out to 0. It will never happen. Also notice that it crosses 1 on the y-axis. Of course, if you put x in a 0, 2 to the power 0 is 1. Let's look at another exponential graph. So here I've got y equals 3 to the power x. So what do we notice about 3 to the power x? Well, it's a little bit steeper. The interesting thing is it also passes through 1 on the y-axis. Of course, 3 to the power 0 is indeed 1. In fact, any constant to the power 0 is 1. So no matter if you have 2 to the power x, 3 to the power x, 4 to the power x, any of these graphs, they'll all go through 1 on the y-axis. Another thing you need to notice is it has the same asymptote. Again, the same thing applies. There's no power you can raise 3 to, which will come out as 0. So 3 to the power x will never be 0. Hence, it never touches the x-axis. And we have an asymptote at y equals 0. Of course, y equals 0 is simply the x-axis. Here we've got 1.5 to the power x, and that graph is less steeper. But like we mentioned, it passes through 1 on the y-axis, and it also has an asymptote. There's no value of x you can choose to make 1.5 to the power of x come out as 0. Now what I'm going to show you here, you need to have an understanding of gradient functions. Now I've done a video on drawing gradient functions, so do go ahead and watch this first. Okay, so I've got y equals 3 to the power x. Now I've drawn some tangents on, so we can start talking about the gradient of this graph at different points. And what you notice, towards the right is very steep, the tangent is very steep, so it has a very positive gradient. And as you start going towards the left, it starts becoming less positive. The tangents at these points are less positive. And if you keep going to the left, the gradient of this function 3 to the power x becomes less and less positive, getting closer to 0. Now it does look like this graph is suddenly going to have a turning point, meaning the gradient will be 0, but it never quite turns into a turning point. So it gets closer to 0, the gradient that is, but it never quite becomes 0. Now let's pause for a minute. Let's look at the actual graph 3 to the power x. Doesn't it have the same pattern? The actual graph itself is very positive as you go towards the right. Now if you start moving towards the left, it becomes less and less positive, and it gets closer and closer to 0. Well, didn't we just say the same thing about the gradients? The gradients were very positive towards the right, and they got less positive, and they got closer and closer to 0. So what we notice is the function 3 to the power x and its gradient function have very much the same property. So when you draw them, they do look very similar. And I've got them both drawn here. I've got y equals 3 to the power x and the gradient function of 3 to the power x. And you'll notice it looks very much similar. And one more thing I'd like to point out is the gradient function is slightly steeper. Now here we've got 2 to the power x and its gradient function. And with this one, the gradient function is slightly less steeper. So just think about that for a moment. 3 to the power x, its gradient function is slightly steeper. With 2 to the power x, the gradient function is slightly less steeper. Let's have a look at them again. 3 to the power x is slightly steeper, and 2 to the power x is slightly less steeper. So what do you think will happen? Instead of using 2 or 3, we used a number between 2 and 3. Something like 2.5 maybe. What do you reckon will happen to the gradient function? Have a look again. 3 to the power x, the gradient function is slightly steeper. 2 to the power x, it was slightly less steeper. Now if you said 2.5 to the power x and its gradient function would be very close, and you wouldn't quite be able to say is it going to be steeper or less steeper, but it will be very similar. Well, there is a value such that it becomes perfectly the same. The function and the gradient function are perfectly the same, and it's a value between 2 and 3. It's 2.718. 2.718 to the power x, and its gradient function is exactly the same. There is no difference. Now I did say 2.718, but this number does keep carrying on. It's an irrational number, just like pi. And we refer to this number as e. And that's the really special thing about e. The function and the gradient function is perfectly the same. So there's no point me drawing the gradient function here, because I'll just be drawing the same graph again. So going back to differentiation, if you have y equals e to the power x, dy dx, the differentiation of it, is e to the power x, the same thing. Okay, so now we're going to be looking at some transformations of e to the power x. So let's say e to the power x is fx. Now this is the first transformation we're looking at, f minus x, which turns ex into e minus x. Now, do you remember what this transformation does from your GCSEs? Hopefully you said a reflection in the y-axis. So this is what the graph of e to the minus x looks like. It's just a reflection in the y-axis. Okay, so let's look at the next transformation. It's minus fx, which turns ex into minus ex. Now what does that do? Hopefully you said a reflection in the x-axis. Again, it's something you've done in your GCSEs. Now we've got both of them. We've got minus f minus x. So it makes sense it's both a reflection in the y-axis and a reflection in the x-axis. So where does our graph end up? Let's reflect in the y-axis first, and then reflect it in the x-axis. So that's where our graph ends up. This is how minus e minus x would look like. Now, it's very important that you note down that in all the transformations we've done so far, the asymptote did not change. The asymptote stayed at y equals 0, the x-axis. Now, it's really important that you remember that. Now we've got fx plus a constant, a. Now in this example, I made the a 1, so you can see what happens. And you should have said it shifts the graph up by 1. Of course, if a was negative, it would go down by 1. Now if it's shifting everything up by 1, of course it makes sense the asymptote also jumps up by 1. So we shifted the asymptote up. Now let's shift the graph up. And this is what our graph would look like. Remember, it crossed through at 1 first, so now it will cross through at 2 on the y-axis. Okay, so these two transformations do much the same thing. They move the graph to the left or the right. With fx minus a, it moves the graph to the right. And if it was x plus a inside the brackets, it'd move it to the left. And with kfx, it does something very similar. It depends if k is between 0 and 1 or if it's more than 1. Basically, if it's a fraction or if it's a number more than 1. That decides if it moves left and right. Now, these two transformations don't normally do the same thing. It's just with exponentials they do the same thing. They both move the graph to the left or right. So it could be like this or the other way. Nothing too tricky. Let's look at our last one, fax. Now this one stretches it in the x-axis. If a is more than 1, it squashes it up. If a is between 0 and 1, basically a fraction, it stretches it. This is an example of what might happen with this transformation. In this case, it's been squashed. Now if I was drawing this graph in a question, and I didn't have ex also drawn in the same graph, I'd basically draw it the same. So I wouldn't have to draw a stretched version because there's no scale on the x-axis, you see. In this case, I had to differentiate between ex and the graph because they're both drawn on the same graph. Okay, so we're going to have a go at sketching this graph. Now, which transformations have been done to this graph? Well, we can see there's a minus in front of the x. So we definitely know there's been a reflection in the y-axis. Notice it's also been multiplied by 5. So this transformation has also been done. And this transformation simply stretches it. It just stretches it in the y-axis. But it's the same thing as saying it moves to the left and the right for exponential graphs. So in this case, it's moved to the left. Just note that AFX, this transformation, normally stretches in the y-axis. Now with exponentials, yes, it also does that. But with the way the graph looks like, someone can look at it and say, no, it's not stretched, it's moved left or right. But both people will be right. So if we apply both transformations, this is what our graph looks like. And if you're sketching it with me, hopefully you got something similar. Now, if you did have trouble drawing the graph in this way, I'm going to show another method. I only showed this method first because I just wanted you to get used to the transformations. The other method I showed is more usable in exams, and it's the way I do it. Okay, so let's find out where it crosses the y-axis. Of course, to find out where it crosses the y-axis, you need to put x in a 0, like we've done here. And e to the power 0 is, of course, 1. And 5 times 1, of course, gives us 5. So y equals 5. So y equals 5 is where it crosses the y-axis. And we can put that on our graph. So if we weren't doing the transformation way, and we're doing this way, the first thing we would have done is worked out where it crosses the y-axis, which we've done. We know it crosses at y equals 5. The next thing we would have said to ourselves is e to the power x will never be 0. And we discussed that earlier. So what I'm doing here is putting e to the power x in a 0. But of course I'm saying y is not this, because we said you can't put e to the power x as 0. So y is not 5 times 0, as e to the power x will never be 0. Which gives us y is not 0. So we just worked out that y will never be 0. Because for y to be 0, e to the power x will have to be 0, which can't happen. So we found out an asymptote. Y equals 0 is an asymptote. It doesn't exist. So we found out two things. We found out that x-axis is the asymptote, and the graph cuts through at 5 on the y-axis. Now, using those two pieces of information, together with the reflections, you should be able to draw the graph. So in the exam, if you had to draw an equation like this, just look at it and decide which reflections have been done. Next, decide where does it cross the y-axis, which we've done also. And finally, decide what the asymptote is. See what y comes out as if you put e to the power x as 0, which can't happen, of course. A constant can't be raised to any power to make it 0. And after you know these 3 pieces of information, you just simply draw the graph. Let's look at this one. We're going to do the transformation method first. So which transformations have been done to this graph? And you should have set a reflection in the x-axis, because we can see that EX has got a minus in front of it. It's been multiplied by a minus. And we also know it's been shifted up because 2 has also been added on. Now, can you sketch this graph? Now, hopefully you got something like this. What I did is I reflected it in the x-axis and then moved the whole graph up. Now, in this case, it's very obvious where it crosses the y-axis, because after it got reflected, it crossed at -1. Then it moved up by 2, so eventually crossed at 1. However, if you're doing the other method, let's go and find out where it crossed the y-axis by putting x in as 0. So e to the power 0 is 1, and we have 2 minus 1 is 1. So we know it crosses at y equals 1. Next is the asymptote. Let's find out where the asymptote is. So e to any power will never be 0. So like before, we're putting e to the power x as 0, but we're saying y will never be this. So y will not be 2 minus 0, which gives y will not be 2. Now this working out I'm doing, you wouldn't do this working out. You'll just look at the equation, imagine that e to whatever power is 0, which it can't be, and see what value y comes out as. And then you can say y won't be this value. Hence, this will be the asymptote. So y equals 2 is our asymptote. And deciding what reflections have been done, you should be able to sketch the graph without doing this whole transformation method. You'll only need to be good at the reflections part of the transformations. And there we have it. I hope you found that video useful. Support us by liking, subscribing, and share this with your friends. And if you still got some more questions on anything, drop a post on our forum at examqa.com where you'll find your questions answered.